In the early months of 2024, a fundamental shift occurred within the architecture of the internet. Though almost no one noticed it at the time, it wasn't a sudden server crash, or a ransomware gang demanding cryptocurrency to unlock hospital records. Instead, between February and June of that year, a silent and highly coordinated operation compromised the internal structure of more than 100,000 websites globally. Millions of everyday users were exposed to an invisible threat while performing mundane tasks like reading the news, shopping online, or checking their bank balances. The infrastructure wasn't breached through brute force or zero-day exploits. The gates were simply opened from the inside, leveraging a system of trust that web developers had relied upon for nearly a decade. To understand how such a massive infiltration happened right in front of the world's cybersecurity experts, we have to look back at the foundation of modern web development, and a seemingly harmless tool that was designed entirely to be helpful. In the early 2000s, web browsers were highly fragmented. Developers wanted to use the latest JavaScript features to build dynamic, interactive websites. But they faced a constant problem. Millions of people were still using older browsers, which simply could not understand the new code. If a modern website was loaded on an old browser, it would break. The solution to this was the Polyfill, a piece of code that provides the technology that the developer expects the browser to provide natively. Essentially, it was a translator. In 2014, a brilliantly efficient service called Polyfill.io was created. Instead of developers manually writing and packaging these translations for every possible browser environment, they could simply insert one single line of code into their website's HTML document, a script tag pointing directly to the Polyfill.io domain. When a user visited the website, the Polyfill server would instantly analyze the user's browser via their HTTP headers, determine exactly what modern features were missing, and send back a custom-tailored package of JavaScript to bridge the gap. It was elegant, open source, completely free, and incredibly effective. Because it solved such a massive headache for web developers, its adoption rate skyrocketed. Over the next decade, Polyfill.io was integrated into the source code of over 100,000 websites, including multinational corporations, media conglomerates, e-commerce platforms, and government portals. It became a silent, invisible pillar holding up a significant portion of the web. The critical vulnerability in this setup was not the code itself, but the nature of how the code was delivered. When a website includes an external script using a source tag, it grants that external server immense power. The host website essentially tells the user's browser to download whatever code is at that URL and execute it immediately with the exact same privileges as the host website itself. This means the external script can read session cookies, monitor keystrokes, intercept form data, and alter the visual interface of the site. For years, this was not an issue because Polyfill.io was operated by trusted members of the open source community. However, in February 2024, the landscape fundamentally changed. The Polyfill.io domain, along with its associated GitHub repository, was quietly sold to a Chinese content delivery network company known as Funnel. Upon learning of the transaction, the original creator immediately issued public warnings on social media, urging developers to remove the Polyfill.io script from their sites. He pointed out the inherent danger of trusting an unknown third party with direct, unmitigated execution access to thousands of websites. Despite his warnings, the inertia of software development meant that most sites left the code exactly where it was. Legacy systems are rarely updated if they appear to be functioning normally, and to the average developer, Polyfill.io was still returning the compatibility code it always had. The true nature of the acquisition became apparent in June 2024. A cybersecurity firm named Sansec, which specializes in detecting digital skimming and e-commerce threats, uncovered severe anomalies originating from the Polyfill.io domain. The service was no longer just providing benign browser compatibility code. It had been weaponized to execute a sophisticated supply chain attack. A supply chain attack occurs when a threat actor compromises a widely used third-party tool, knowing that by poisoning the source, they can automatically infect every single entity that relies on it. When Sansec analysed the network traffic, they discovered that the new owners of Polyfill.io had modified the delivery server to dynamically inject malicious JavaScript payloads into the code sent to users. However, the attack was meticulously designed to evade detection. The malicious server did not send the infected code to everyone. It employed advanced cloaking techniques, checking the user agent strings and HTTP headers of every incoming request. If the server detected that the request was coming from a system administrator, a web analytics crawler, or a known cybersecurity research IP address, it would serve the standard, harmless Polyfill code. This ensured that automated security scanners and developers checking their own sites would see nothing out of the ordinary during routine audits. The malicious payload was primarily targeted at mobile device users accessing the internet during specific timeframes. When the server confirmed a vulnerable and valuable target, it appended heavily obfuscated JavaScript to the legitimate response. The attackers used dynamic code evaluation to hide their tracks. Instead of writing the malicious commands in plain text, the code was scrambled and would only assemble itself into executable instructions once it was safely inside the user's browser. Once this code executed within the document object model, or DOM, of the host website, it bypassed standard security protocols like the same origin policy. The primary function of this injected malware was to execute conditional redirects. Without any input from the user, the script would hijack the browser session and force redirect the user through a chain of intermediary domains. To hide this network activity from firewall monitoring, the script often disguised its outbound requests by formatting them to look like standard Google Analytics telemetry data. Ultimately, these redirects landed the user on illicit sports betting sites, malicious applications, or fraudulent phishing pages. Because the initial redirect originated from a site the user trusted, like a major news outlet or an online store, the success rate of the scam was significantly higher. Furthermore, because the script had full access to the DOM, researchers noted the potential for even more devastating actions, such as capturing login credentials or credit card information inputted by the user on the legitimate site before the redirect ever occurred. When Sansec published their findings in late June 2024, it triggered a massive shockwave across the global tech industry. Security teams scrambled to audit their codebases. High-profile platforms, including major streaming services, domain registrars, and various national government sites, were found to be actively pulling the poisoned script. The response from the broader internet infrastructure community was unprecedented in its speed. Recognizing the immediate danger to millions of users, major content delivery networks intervened. Cloudflare and Fastly quickly set up secure, sanitized mirrors of the original, uncorrupted Polyfill repository. Cloudflare went a step further, implementing an automatic interception at the network level. For any website routed through Cloudflare's infrastructure, if the site's HTML attempted to call the malicious Polyfill.io domain, Cloudflare would intercept the request on the fly and seamlessly rewrite it to pull from their secure mirror instead. This essentially neutralized the threat for a massive portion of the web instantly, without requiring the individual website administrators to manually update their code. Shortly thereafter, domain registrars suspended the Polyfill.io domain entirely, effectively cutting off the attacker's ability to distribute the malware. The Polyfill supply chain attack remains one of the most significant cybersecurity events of recent years, not because of the complexity of the malware itself, but because of the sheer scale and the method of delivery. It exposed a fundamental fragility in how the modern web operates. Developers today build applications by assembling hundreds of open-source building blocks, trusting that the maintainers of those blocks remain benign. The 2024 attack proved that threat actors no longer need to breach firewalls or crack passwords to compromise a corporation. They only need to purchase a forgotten domain or acquire a widely used code repository to turn the internet's collaborative foundation into a weapon. It forces a critical re-evaluation of digital trust and serves as a stark reminder that in a highly interconnected digital ecosystem, a single compromised link can silently poison the entire chain.